Hi there, and welcome back. It's Mikhail here. In this video I want to talk about dependency injection. On the one hand, it's a fairly simple concept. On the other hand, it's always a heated topic of discussion. So many men, so many minds. There are different approaches, libraries, and opinion on how it should be done. We will go through this topic in general, and in the end of the video I will present a small library for Flutter that I recently created. If you are new to the channel, do not forget to subscribe so you won't miss future videos, and for everyone else, grab your coffee and let's get started. To begin with, it's worth understanding what dependency injection actually is and why do we need this at all. We do not write our code as one big scary function. Instead, we split it into different pieces, different areas of responsibility. In object-oriented programming, it usually means different classes that encapsulate specific parts of system behavior. At some point, when one class A requires another class B job result to perform its own job, a dependency arises. Class A depends on class B. Once a dependency exists, the next question is, how do we actually provide it to the first class? And the most straightforward approach is just create it right where it's needed. And for really small or trivial case, it won't even be a problem. However, in the real world, this approach quite quickly becomes insufficient, even for basic scenarios. Imagine a simple case when the same dependencies is required for multiple classes, and it should be the same instance for work synchronization. If each class creates dependency on its own, they will all end up working with the different objects. This is where the situation becomes more complicated. Instead of creating everything locally, we need a way to provide dependency from the outside. And this is exactly an entry point for dependency injection. So dependency injection is just a process of providing a dependency to a place where it's needed. And how we actually inject a dependency. In practice, there are very few common ways to do it. First of all, constructor injection. In this case, we provide a dependency directly into the constructor and store this inside the object. This is the most common way to do this because it makes dependency explicit and ensure that the object created in a valid state. Another one is method or parameter injection. In this case, dependency is provided as a parameter to a specific method that needs it. This works well when the dependency is required for a specific operation rather than entire lifetime of the object. And the last one is property or field injection. In this case, a dependency assigned after the object is created via public property, setter, or whatever else depends on the language. This approach can be really convenient for specific cases, but at the same time the easiest one to misuse. At this point, you might notice that every single mechanism we already discussed is available out from the box in virtually every modern programming language. And if you're using them, it means you already have a dependency injection. So where do all these debates, controversies, and multiple of approaches I mentioned in the beginning of the video come from? So the reason is funny. Every time then we say that we talk about dependency injection or creating something for dependency injection, we actually do not touch dependency injection itself. There is very little to argue about. Instead, most discussion revolve around a whole set of concerns that come together with dependency injection. Things like dependency container, inversion of control, object lifecycle, who and when should create and dispose of object, who is the owner of object, and who manage all those things. Exactly these topics introduce complexity, trade-offs, and even different design philosophies of dependency injection. In this part, I want to talk about my personal preference when it comes to topic related to dependency injection. These are not strict rules or universal truth, but just a set of principles that I've arrived at during work on the different projects. It's also important to know that all these preferences are strongly influenced by specific domains I work in. and worked in for a long time. Since 2019, I've been totally focused on mobile development with Flutter. And before that, I spent several years to work in game development. Both of these areas are highly visual and user-facing by their nature. They are not like a console application or backend system, and that's context matters a lot. Many of choices that I make around dependency injection topic are shaped specifically by needs of this kind of development. And if I were work in a different environment or with a different technology stack, I would naturally reevaluate all those preferences based on the realities and the constraints of a specific context. That being said, let's move to the preferences that I mentioned. One of the key points is that the dependency management, the management itself, is a crucially important process that affects every single part of your application, the entire application. Because of that, I strongly believe that this process should be centralized. It's extremely convenient to have a single place, a single component or class that's responsible for managing dependency globally. This makes it much easier to reason about how object created, shared, disposed of, and gives you a clear overview about the dependency graph of the application. The first thing that usually comes to mind when we talk about centralized way of dependency management is a service locator pattern. And I want to make it clear right away, I'm not a big fan of this approach at all. Conceptually, there are ideas behind it which I do appreciate, like combination of registering, resolving. However, overall, I see numerous serious drawbacks which overweight for me all benefits in most cases. More precisely, these drawbacks stem from the way how this pattern is usually used in practice. Usually there is some global object that's accessible from any place, any time. You can take whatever you need from this object and just continue work. For me, this approach leads to a whole range of problems. Hidden dependency, hidden complexity, reduced stability, unclear ownership, and poor control over object lifecycle. On the long run, it leads to the system being in a state which is hard to maintain. Another very important point for me is being able to flexibly control object lifecycle, being explicit when an object is created, how long it lives, how it should be disposed of. And it's crucial for large and long-living application with long user sessions. Without clear lifecycle management for object, it becomes quite easier to turn short-lived object into global one, keep resources alive longer than it's needed. That easily goes to memory issues, unexpected behavior, and really complicated bugs to track down. And it's not enough for me just being able to lazily create object and that's it. I also want to have ability to destroy it and not formally have a dispose method that is exist and never been called, but actually being able to define exact moment when an object should be cleaned up and released. Many developers probably encountered a situation when some logic exists in a place where it's clearly not belong, just because that class technically exists. For example, user profile logic contains handling of authentication states to handle case when user is not authenticated at all or logged out. In this case, the problem is not logic itself, but the fact that the object should not be alive in this particular state of the application. Based on these preferences, I built my own small library for dependency management for Flutter that's called Scope Manager. In this part of the video, I will briefly talk about it, what problems it aims to solve, what design decisions were made, and most important, why those decisions were made. I will also give a short demonstration how it works in practice so you can get a general feeling on the ideas and how this principle translates into real code. The main focus of this library is dependency lifecycle management. That is creating dependency, keeping them alive while they need it, and then disposing of when they are no longer required. This management is not done on an individual per object basis, but rather in group. At the core of the library lies an idea that most dependencies, they are not needed in isolation. They appear, exist, and are removed together, serving a shared purpose. Because of that, dependency management can introduce a concept of a scope, a group of dependencies that share the same reason of existence and the same life cycle. When the scope becomes relevant, all dependencies belong to this scope are created. And when the scope is no longer needed, everything inside can be safely disposed of altogether. At the same time, in addition to those situational or temporary dependencies, there is always a set of dependencies that mean to be alive the entire lifetime of the application. They cannot be disposed of conditionally. They are always needed and should exist as long as the application is running. To simplify working with such dependencies, Scope Manager introduces root scope. Unlike temporary scope, the root scope is permanent, always available and accessible regardless of current application state. It acts like a foundation for entire dependency graph and serves as a stable place of global long-lived dependencies. When it comes to actual implementation of a scope, I deliberately choose to leave this completely free. I don't see any real need to enforce how exactly scope should be implemented internally. By the way, in my opinion, the tools provided by the language itself are more than enough to shape this group of dependencies. Everything that we need is available out from the box. If we need laziness, we have a special word late. If we want to keep the same instance, we can store this inside the scope and share it when it's needed. If we need a fresh instance every time, we can create a factory method that returns a new object every time it asks. Because of that, the concrete implementation details are intentionally left up to the developer. In this case, it's really, as they say it, up to you. The next important piece is managing scope themselves. As I mentioned earlier, scopes is a group of dependencies share the same purpose. And since the purpose can change greatly from application to application, there needs to be a common unified way to create and dispose those scopes. For that reason, the package introduces a single manager responsible for the life cycle of scopes. This manager keeps tracks existing scopes, create them when they're necessary, and dispose of when it's not longer needed. The decision of when to create or remove a scope is handled through a subscription-based mechanism. When some parts of the application becomes interested in a particular group of dependencies, it declares that interest by subscribing to the corresponding scope. As soon as the first subscriber appears, the manager creates the scope and keeps it alive. When a subscriber no longer needs the scope, it unsubscribes from it. And once the last subscriber unsubscribes, the scope is disposed of automatically by the manager. Even though a subscriber can technically be anything, in practice, especially in visual-driven application, it's the most often some part of the user interface. For example, appearing of the specific screen. To make this easier, the library provides a set of utilities such as mixins to allow you conveniently bind visual configuration, a widget, and a specific scope. This makes subscribing and unsubscribing to scopes a natural part of UI lifecycle without scattering lifecycle management logic across the code base. Let's now take a look at a practical example of how this library can be used. I've prepared a small demo application specifically for this purpose, so we can walk through a simple scenario and see how Scope Manager behaves in practice. So first of all, we need to include this package into PubSpec of our application, and this way we can get everything that the package provides for us. The next step, we need to define our scopes group of dependencies. I created a few of them. Global one, root scope, which I mentioned, that will alive during the whole life cycle of the application. For demonstrational purpose, I put here only one dependency that we will use, this counter. This is a simple class which has a value identifier and few methods. And also we have a feature scopes which will be created on demand. Their implementation looks similar, but the purpose is different. So they will be creating and disposing when we decide to do this. They also contains the similar dependency, also just a counter, which will hold this information for us. And after we do this, we can go to registration of those dependencies. To register dependency scopes, I created a simple method in the main function and just used those scope manager, the global instance that we have, the single instance. So it's a singleton, which contains information about how to create scopes and which scopes are created currently and all that stuff. So we register there functions that can resolve those scope of dependency. And after we finish this, we can go directly to the application. This is a simple application which contains two different parts. On the one part, we have a example application that we operate with. And on the other part of this application, we have some observability helper that show us which dependencies are created, which dependencies are not yet ready. Let's run this and see how it looks like. Now application is running and we can see that in the tracker part there is no subscriber, no active scopes, we only have a root scope. So we can open our screen, first screen, and we can see that we have one subscriber for our feature one scope, which leads to create for us this scope instance. And being on this page, we can interact with those dependencies, those counter that we created there and store in the scope of dependencies. And also we can interact with the global one as well. So as soon as we leave this screen, we don't have anymore someone who intend to keep this bunch of dependencies alive. They are disposed completely and cleaned. So if we go again, our feature scope dependencies, they will be recreated from scratch. We again see that here's a subscriber, here's a scope, active scope, and we can again use them. As long at least one dependency subscriber is alive, our scope is alive and we can operate with it. The same with the different screens, and we can see that our global dependencies, they are still alive, and the feature dependencies, they are created on demand. So how it is implemented, let's take a look. The first screen uses specific mixin that says that this part of UI is required to keep some feature scope alive. And while this written that way, it's automatically inside those life cycle of this state is make a subscription, unsubscription when it's disposed, and providing for us a getter to getting those scopes as well. Of course, you cannot use this mixin directly and operate with this manager by yourself, doing this in lifecycle methods, or even if you don't want to operate with the user interface part, the configuration of what you want to show. You can also do it from any place you want, but the logic's still the same. At this point, we arrived at some wrapping up. The goal of the library is, of course, not replace every existing DI solution or claim this approach as universally better. Instead, the Scope Manager is a practical answer to a very specific set of problems. Predictable lifecycle management, explicit ownership of dependencies, and clear boundaries that match the structure of the application and the state of the application. If these ideas resonate with you, feel free to explore the library, try it out, share feedback, and even if you don't end up using Scope Manager directly, I hope this video gave you an interesting perspective on how dependency management and lifecycle control can be approached. Thanks for watching. Don't forget to like, subscribe, and all that good stuff you already know. This was Mikhail. See you in the next video. Bye.